Parabolas. Now, on this first example, it says match the following function with its graph. So whenever we're wanting to graph something on the Cartesian coordinate, we usually create an XY table and plot it. So what I'm notice here, a parabola is always going to be a power of 2, right? And this is the function or equation that was given to us. So if I was to go graph y equals x squared and create my XY table, and I know everywhere that I plug 0 in for x in this particular function, I get 0 for y. I can plug 1 in for x, I get 1 for y. If I plug in 2 for x, I get 4 for y. If I plug in -2 for x, I get 4 for y. So if I go plot these points, which you notice over here that I have plotted them, this would be the y equals x squared function. However, in this one here, we have more going on than just y equals x squared. So whatever we have going on here, we're going to make those changes here. So let's just look at it. This particular function's formula should be y equals, and you can use uppercase a or a lowercase a, times x minus h squared plus k, where my h and my k will be the vertex of the parabola. Let me clean this up just for a second. Okay, so what am I talking about, the vertex? So of a parabola, it would be this point, right? Okay, so let's look at it a little bit more. I'm going to clean this up. So we're good. Let's get started. And what do I notice about each part in this function? Well, I notice that if I was to go list it, my a is equal to 1/5. My h here, well, remember, it says minus h here. This has a plus h. That means x minus a -4, right? Because negative times negative is positive. So my h here is -4. My k is 3. It's positive because it didn't change the sign, right? So right now we know enough to determine what happens. So if h represents the y value, right? Or excuse me, my apologies, let me backtrack. If h represents my x value, then you agree x will determine if we move to the left or to the right. So if my h value is greater than 0, right? So a little note, let me change this right quick. Let's go with this pink. If h is greater than 0, that means it's a positive number, right? We're going to move to the right number of units. However, remember in college algebra, this is the opposite. It flips. It's a little bit different. This is trig though, so we're doing it this format. If h is less than 0, meaning it's a negative number, then we're going to move to the left, the number of units. All right, so if you notice, this one here is negative. So that means we need to move this whole entire graph to the left. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so I moved it to the left. Now let's look at K. K represents the Y value, right? So that means if it's positive, it goes up. If it's negative, it goes down. In this case here, it's positive. So I'm going to raise it. Let me change this right quick. We're going to raise it 1, 2, 3. 1, 2, 3. 1, 2, 3. So we got this so far. Oops, based upon that. But let's talk about A. A says that if it is, if it's greater than 1, okay? If A is greater than 1, then we have a stretching going on. What do I mean by stretching? A good example is C here. We have the stretching going on. If A falls between 0 and 1, well, then we have a shrinking going on. Well, look at what A is. A is 1/5, so it is less than 1. It's actually going to fall between 0 and A. Or excuse me, A is going to fall between 0 and 1. So we have shrinking going on. So that means that these arms are going to spread out, meaning that instead we're going to have a stretching, we're going to have more of a, it's going to come. I'm not saying it's going to be that wide, but I'm just saying it's going to start spreading out, like opening your arms more. So think of it as stretching when you put your arms above your head and you stretch real high versus when you're shrinking, you're bringing them down like almost level with your shoulders. So it just depends on what A is, how much shrinking you're going to have. So let's look at this. Well, we can rule some things out because A is positive. If A was negative, then I know my parabola would have opened downward, but since it's positive, it's going to open upward. So we're going to mark B out. We're going to mark C out because that's a stretching and we know we don't have that. Also, when we plotted our graph, you notice it's above the x-axis. D is below the x-axis. So A is my answer. So those just have a really good image of it. This one here, I pulled from the online graphing. So now let's look at example 2. Example 2 says the graph shows a parabola along with the vertex and the focus and the districts. Determine the coordinates of the vertex and focus and the equation of the districts. So let's look at it. My vertex, again, it's like the splitting point of the parabola, right? The belly of it's what I like to call it. So if I look at it, I notice that right here is my vertex. So that ordered pair is going to be 0, 1 because it's on the y-axis, so x is 0. Now my focus is either above or below my vertex. So right there it is. So that is going to be 0, 3. Okay, and it could be below it in some cases, depending on what we're working with. All right. Now, I like to recognize the axis of symmetry because there may be a time when you need it. Axis of symmetry is what splits the parabola completely in half. So if you'll notice, right here on the y-axis, whoops, that is definitely a bad drawing. Let me change it real quick. Right here on the y-axis is what's splitting it in half. And what is it there? That is where x is 0. And again, I called this my axis of symmetry. Okay. Now, let's figure out what's our districts. Our districts is going to be the y value in this case, right? It's going to be at the distance. So what I want to do is I notice I have the focal point here, right? And I have the vertex, and I need to figure out the distance between them. So I'm going to take, and we're solving the y value, right? So I got 3 minus 1, which gives me 2. So I know that in this case here it's 2, right? Because it is 2 units away from it. Also, if you was to look below it and find its districts below it, which is the line is drawn, it's already telling you what it is, but we can also figure that out. Again, we could say, oh, wow, it's at 1 again here. And we're going to subtract the 2. I get -1. Check, that's where it fell. But they gave you that one. Okay, let's do example 3. Find the equation of the parabola with the given focus and detrits. We're given the focus of 2, 8, and we are given the detrits of y equals 1. So I'm going to write some formulas down for you. It's important that you know these formulas. Write them to the side with your formula sheet, whatever helps you, okay? This is going to be important. It's going to benefit you. So let me get those. Okay, it is right here. We have the focus of h comma k plus p. We have our detrits of y. Oops, let me clean that up, okay? Y equals k minus p. Of course, we know our formula is y equals a times x minus h squared plus k. Let's find a. If you don't know a, the formula is 1 over 4p. And then the vertex. Well, we know the vertex is h comma k. So if you need to, I would have that on a separate sheet. These are helpful informations, plus the information on how to graph a parabola to you as well. All right, now let's solve for this one. So there's multiple ways that we can start first, but let's make it easy. First thing is, let's recognize what's our vertex. So when I look at what my vertex is, I'm not sure, right? So let's go back and determine our distance, our directress. So if I was to do it first, I know that I'm going to take the y value from my focus, right? And subtract my y value right here that was given to you. Now I know that it's 7 units. That's my detrits. There's 7 units. I like to always go to the vertex first because usually it's like real obvious, but that's why I started with that one, but it's not there. Okay, so the distance between the focus and the detrits is 2 pi, or pi, not pi, 2p. Sorry. So let me write that down. It's 2p. And if you notice this little blue dot right here, right there, that's the focus. That's the order pair 2, 8. All right, now what I'm going to do now that I know that, I want to take, because we know that we have, let's solve for this right quick, my apologies. So I have 2p. I'm going to set it equal to my detrits. And if you want to write this out, you could, which is 2p is equal to 7, divide by the 2. And now my p is 7/2. Now that I know this, right? Now that I know this, I'm going to come over here and say, okay, a equals 1 over 4 times p, which is 7/2. Well, I'm going to save myself some extra work because I see the 4 and the 2 reduces. So now I'm left with 1/14. So I know what a is. So moving on to the next step, now that I know what a is, I want to figure out what k is, okay? I'm going to give you the formula for it right quick. And we're solving for the, change this up right quick. Okay, so let's find k. Well, k is going to be my y coordinate of my focus plus my directress y value all divided by 2, which makes sense. I'm adding 2 together. It's like finding the average, right? So I got my y value, which is 8 for my focus, and my matrix, which this says y equals 1, right? So we're going to add 1, all divided by 2. So that gives me k is equal to 9/2, right? And now that I know all of that, I can turn around and plug that all into my into the function that they're asking us to create based upon the information given. So I know that y is equal to my a, which is 1/14, times x minus, what is my h? When we look at what our h is, we're going to come here and look at the x value of the focus, because remember, the vertex is going to fall the same as the x value of the focus if and only if we're working with the regular formula. Now, if we ever switch x and h, then there's going to be something different about it, but we'll talk about that when that comes. So it's going to be, since this is a positive 2 here, it's going to be just x minus 2 here, plus my k, which is 9/2. So that is my function for when the focus and the matrix is this. So moving on to our example 4. So now let's determine the vertex, the focus, the matrix of the following parabola. Now, so it won't be too hard to figure out the parabola here, or the vertex here, right? Because it's written in that formula form. And remember, the vertex is h comma k. Well, what is h here? H is 3. Look at k though. It says -50, and k here shows that it's a positive. So then that means it's actually a -50, right? Because a positive times negative gives me the negative. So we know that. 3 is positive because we didn't change the equation for that. All right, so now so we got the vertex. Let's just write it in order form, order pair, I mean. So that's my vertex. Now let's figure out what's the focus, but before we can go any further, we need to figure out what P is, because remember, focus is going to be H comma K plus P, and I don't know what P is. So we're going to use the formula of A equals 1/4P. I know what A is though, so that makes it easier. I'm going to say 5 is equal to 1/4P, and now let's multiply both sides by the P so we can undo or pull it out of the fraction, right? So once I've done that, now I have 5P is equal to 1/4, and I need to divide by this 5. So now I have P is equal to, well, we're going to keep, change, flip. So I got 1/4 times 1/5. So my P is 1/20. So now that I know that, let's solve for the focus. So H is 3, comma, K is -50, and P is a positive 120. So now let's solve for it. That equals, well, we need a common denominator, right, in order to add this fraction. So I see 20 is going to be my common denominator. So I'm going to multiply top and bottom by 20. So I got -50 times 20 all over 20 plus 120. So when I multiply that 50 times 20, and I'm just going to come down here and finish solving this one. I get -1000 plus that 1/20, means that my answer is a -999/20. All right, so let's finish writing our order pair out for this one. So it's going to be 3, -999/20. So we got our focus, we got our vertex, right? This is our vertex, our focus. Now let's find our districts. So when we're solving for our districts, that formula, and maybe I need to do this, is going to be y equals k minus p. So I have y is equal to, and my k is negative 50 minus the 120s. So let's solve for it. Again, we're going to have to find the common denominator, and it's 20. Let's solve. So I got negative 50 times 20, all over 20 plus minus the 120. That gives me a negative 1,000 minus 1 over 20. So my answer is a negative 1,001 over 20. So now we have answered all the parts. Okay, let's move on to example 5. Example 5, we're going to complete the square to write the following equation form. Y equals a times x minus h and all squared plus k. All right, so let's look at it. What do we got going on? We have this function going on that's not written in that format, so we have to do some work. So I'm going to focus on this part right here that I just highlighted. Let's factor out the common or the greatest common GCF, greatest common factor of the coefficients here. We're not factoring out the variables, not the x. And I notice I can factor out a negative 2. So it leaves me with this. And I'm going to leave some space because remember, here, let me just do this one step. That means I'm going to divide by negative 2, divide by negative 2, right? So what do I have here? I have y is equal to negative 2 times x squared minus 2x. I'm going to leave some space here plus that 3. Now, this negative 2, don't forget about this negative 2. We're going to deal with it too. We have another operation for it. But right now, what I want to do is focus on that one term that's going to make it a perfect square. Okay. I'm just cleaning this up. So we're going to have to use b over 2 squared. Well, my b here is negative 2 divided by 2 all squared. That means I got negative 1 squared, which is just 1. So I'm going to add 1 here. So let's talk about that right quick. Remember when we do completing of the square, we always in college algebra had it set up to equal, and we put the constant on the other side. Well, in this particular intrigue, we're not doing that here. One, we got to figure out what goes over here to be added to this other side, because we can't just change part of this. We have to change all of it. So when I look at it, I see that I got this negative 2. In order to put it back here, I need to go with the opposite, right? So if it's negative, it's going to be positive. So what I'm going to do is take that positive 2, and I need to multiply whatever I put here by it. And then I'm going to add it to this plus 3. So when I do that, now I get y is equal to negative 2x squared minus 2x plus 1 plus 2 times 1 is 2 plus 3, that's 5. Boom. I got it written in the format now. I got one more step to get it completely in that format, but I got it in the format that I needed. So now I want to focus on this part right here. And I'm going to write it in its perfect square format. like this, right? So I know that X is going to lead it. I know that I need a product of 1 that will multiply and add. So another way to look at it is whenever we talked about parabolas, we got ax squared plus bx plus c. I put 1 there, sorry. We're going to take a times c. Well, in this case, a is 1, c is 1, gives me 1. And look at this, the sign here on c is add, so it's a sum that adds up to get my b, and my b here is -2. Okay, so knowing that, I know 1 times 1, right, gives me 1. I also know that if I said that I had -1 times -1, well, that also multiplies and gives me +1, so we're good. But -1 plus -1, well, that gives me -2. So my perfect square would be -1 here. That makes sense. So if you're ever in doubt, you can, put them back in the format of this times this and use the full method or the distributed method to figure out if it gives it back what you start with. If it does, then you know you're good. Okay, so now let's finish this up. I want to write this. Oops. And we have our function in that formula form. And that is all that it asks for, I believe. Find the vertex, the focus, and the directives. Okay, we're almost done then. The vertex is going to be easy too, right? The vertex was h comma k, so my vertex here is going to be 1 comma 5. We're good with that. Let's see, the focus is going to be, oops, apologies, hit a button. Focus is going to be h comma k plus p. Well, 1 for h. What is my p? Have we figured that one out? We have not. So let's look at it. We're going to use the formula of a equals 1 over 4p. We know what a is. A is -2. I'm going to multiply the p by both sides, right? To undo that, to get it out of the fraction. So now I got -2p is equal to 1/4. I'm going to divide by the -2. I'm going to keep doing these extra steps. You don't have to. That gives me p is equal to 1/4 divided by 2. Let's do k, change, flip, keep, change to the multiplication, flip. Oh, and don't forget your negative sign. So now p is equal to a -1/8. Ah, awesome. So I got my k is 5, and it's supposed to be plus, right? The formula says plus, but positive times negative is a negative. And now we're going to finish this up. Right, so now what do I have? I have 5 minus that 1/8. I need a common denominator, and we see that it's 8. So I'm going to multiply top and bottom here by 8. So I got 40 minus 1 divided by 8, which is going to be 39/8. Now let's write our answer in order pair form. All right, almost done. Now let's find our digits. That's going to be y is equal to my k plus p. And double check on the formula if you need to. That's what I'm doing, I'm checking. So I got, I believe it's minus p. Double check. It doesn't hurt. Let me pull my formulas up. Yes, minus. Okay. So now I got k. Whoops. We know what k is. K is 5 minus my p, which is -1/8. That negative times negative gives me a positive. I need a common denominator because I'm adding fractions, which is going to be 8 times 1. Now I have 40 plus 1/8, which is 41/8. So this, I ran out of room, it's 41/8. Okay, now moving on. Number 6. We're going to find the vertex, the axis of symmetry, the x-intercepts, the y-intercepts, the focus, the districts of this parabola. Look at this parabola closely, guys. This function is equal to x, and we have y here. What happened? They flipped the x and y. The x and y has flipped. It's no longer y equals a x minus h squared plus k. So what we're going to have to do now is recognize now that it's x equal a times y minus k squared plus h. So if the x and y switches, so does the k and h. Because remember, y goes with k, x goes with h. Just because the order switched in the function doesn't mean that you trade up on the values on the Cartesian coordinate, okay? So we're still going to use the formulas, but let's rewrite the formulas down because they're going to be just a little bit different, but yet the same, right? So we have the focus, and it's h comma k plus p. Well, that didn't change, right? My directress. And now it's going to be x equals h minus p. That changed. X equals a times y minus k all squared h plus h. My a is still 1/4p, and my vertex is still x comma y, which is h comma k. All right, guys, this is important that you understand this. When we were working with this format here, the parabola opened upward or downward, right? Now we are working with a parabola that opens to the side. Okay. Now, let me clean this up so we can get started and solve this one. Okay. All right, so what I want to do is I recognize what my vertex is. So let's go ahead and acknowledge it. Well, this is H and this is K. It didn't change the signs from the formula, right? So it's going to be a +5 and a +4. So we're good. Axis and symmetry. Remember, I told y'all earlier that if we had a parabola, that opens upward or downward, I told you it splits it in half, and it was the x value of the vertex for the axis of symmetry. But now we have a parabola that opens to the side. So if it opens to the side, the y value becomes the axis of symmetry, the y value from the vertex. So my axis of symmetry here is going to be y equals 4. All right, I'm going to clean this up. I'm going to go ahead and erase this so I don't have a lot of writing on the screen. Now let's do our next part. So you could find the x-intercepts and the y-intercepts if you want now. So let's go ahead and do it. We'll check it off. I'm going in the order that's in my sentence here. So let's look for this one. So when it crosses the x-axis, we know that y is 0. When it crosses the y-axis, x is 0. So if I said, okay, I want to find the x-intercept, I'm going to plug in 0 for y. So now I get negative half times negative 4 squared plus 5. Negative half. Negative 4 squared is 16. And I'm going to rewrite this as 1 times 16. You can reduce now if you wanted to, but I just wanted to show you where I get my answer. And then half is negative 16 is negative 8. Oh, and I wrote 8 down because I was looking at the answer. That should be 5. So negative 8 plus 5 is going to be negative 3. So my x-intercept is going to be negative 3 comma 0. Now let's find our y-intercept. My y-intercept, we're going to plug in 0 for x. Okay, now I want to do some work here. I want to get, there's a couple ways we can do this, but I'm going to do the easiest and most efficient way to do this solving here. So I'm going to go ahead and subtract the 5 from both sides since it's positive there, right? I want it to go away. So now I got negative 5. No, just leave it like that. All right. I want to get that. Okay, in order to pull y out of that parentheses, it's been squared and it's been subtracted by the 4. I have to get the coefficient on the outside of the parentheses as a positive 1. And then if you notice, what we got going on here is we got a negative half. So I'm going to multiply by the reciprocal. So that negative times negative is positive. 2 over 2 is 1. 1 over 1 is 1. So this here goes away. And what I do to one side, I have to do to the other. You don't have to leave that 1 in there. I'm just doing it for a visual aid. So now I got negative 2 times negative 5 gives me a positive 10 is equal to my y minus 4 all squared. Now I want to undo this square so I can get y out of there. So I'm going to take the square root. And since the square root is even, when I take the square root of this other side, I get a plus or minus. So now I got plus or minus square root of 10 is equal to y minus 4. Now let's add the 4 to both sides because I want y by itself. I want y to have a positive 1 coefficient and by itself. And I'm going to bring the y to the front. So now I got 4 plus and minus square root of 10. So when I write this order pair, I'm going to write it up here. I'm not going to write it. I can write it above it. No, I'll write it below it. Okay. I'm trying to keep it from being too messy. So I know x is 0, and then I get 4 plus square root of 10. And then x is 0, I get 4 minus square root of 10. So that is my y-intercept. Now, let's figure out what our focal point is, right? We talked a little bit about it. We kind of saved it for last for whatever reason. You could have done it first. That's all right. If you notice, though, in the formula to find the focal point, it has P involved, and we don't know what P is. So we're going to go and use the A equals 1 over 4P to find P. Well, I know what A is. A is a negative half. I'm going to set it equal to 1 over 4P. I'm going to multiply both sides by that P. So now I have negative half P is equal to 1/4. I'm going to multiply both sides by this negative, but I'm going to do the reciprocal 2 over 1 instead of 1 over 2. Do the same thing over here. So now my P is equal to a negative 2 over 4, which is a negative half. Okay, now that I know that, I'm going to scroll down so I can have more room. I can solve for my focus. So my focus, again, it's going to be, and if you need to, we can write it, look right back up here. It's going to be H comma K. We need to figure out what the H and the K is again. So let's look back up. The H is 5 and the K is 4. And it said that we're going to have K plus P, right? So I'm going to have 4 plus that negative half, which is going to be 4 minus half. And I'm going to put 4 over 1. I need to find the common denominator. In this case, it's 2. So now I got 4 times 2 is 8 minus 1 over 2, which is 7 halves. So now my order pair is 5 comma 7 halves. We're almost there. Now let's find the dittrix. Okay, so to find that, we know that the formula again, because we did have switch our x and y's, it's going to be x equals h minus p. So I'm going to take h equals x minus p, right? Because that's what it gave us. And if you're not sure, we can always double check back with our formulas again, just to make sure. And I wrote my H and X backwards. I thought it kind of looked funny. I have moments where I just have to go back and check my notation. Notation is extremely important. All right, so my H we said is 5. My P is a negative half. And what I want to do now is notice that negative times negative is positive. So I got 5 plus half. I'm going to put 5 over 1 because I need a common denominator. In this case, it's 2. So now I got 10 plus 1 over 2, which gives me 11 halves. And that is my dittrix. And that was it. That ends it.